Hello, hello, hello. Are you able to hear me?
Yes.
Okay, that's great. So let's start our session today. Let me first of all share my screen. Okay. So we started Neuro, we discussed tracks, we discussed the motor descending system. We also discussed how different motor planes are made within the brain and how they just come down and execute a motor activity. Today we are going to discuss something called cerebrospinal fluid and ventricular system of brain, right? After that, we'll be discussing basal ganglia. If you guys remember, I just told you what's the function of basal ganglia in the function of your motor activities. And apart from that, we'll also be discussing the blood supply of your brain. Once we are done with it, tomorrow we are going to discuss the brain stem then, okay? So you guys would know where different arteries are lying, where different descending systems and everything, your tracks are lying. So it's really better to start with ventricular system today, right? Okay. So, look, anyone have any idea what is CSF? Anyone?
Cerebrospinal fluid. That's value is 150,
Okay.
and it provide nourishment and protection to the brain.
Okay, that's perfect. So CSF is basically cerebral spinal fluid. What's the function of CSF, right? So mm, it's a lot of function as is. The main function is just keep this thing in mind that every fluid basically provide a buoyancy force. What do you mean by buoyancy force? Like you guys might have done a numerical in your physics that it's really hard to push a boat on ground, right? If I have a boat and I just tether it with a rope and I just tell you to pull it on the ground, it's really difficult for you, right? But if the same boat, thousands of kg boat, is present within the water, so you can easily pull it, right? The reason is that fluid basically provides a buoyancy force, right? A buoyancy, which is going to hold the entire weight of your boat in this case. Same is the case with cerebrospinal fluid, right? So cerebrospinal fluid, whenever it's present in a proper quantity within your brain around your spinal cord, it's going to provide a buoyancy force, right? And due to that, the weight of your brain is going to be really less due to that buoyant force, right? What if we have less CSF, right? So till now we know that CSF basically provide buoyancy. If you guys remember it from your chemistry or your physics lecture, buoyancy, which is the force which fluid provide against, any, like in this case, it was board. The CSF again is a fluid. It would just provide an opposite force, which will just try to balance the weight of your brain. So whenever your brain and spinal cord are present around this cerebrospinal fluid, so the weight of the brain and spinal cord would be reduced. It would be, floating within that water, within that CSF. So it means that whenever the CSF is less, right? Whenever the CSF is less, can I say that now the weight of your brain is going to be very high? Can I say because that buoyancy force is going to decrease? Am I right?
Yes, sir.
Hello?
Yes.
Okay. So you can just imagine if this is your brain, okay, your spinal cord. Around it, we are going to be having, this CSF fluid which is surrounding, which is going to decrease the weight of your brain and spinal cord due to buoyant force or buoyancy. And as the CSF decreases, so you can see that the weight of the brain is going to be really high, and the brain is going to move downward through the foramen magnum due to increased weight. Does that make sense?
Yes,
Hello?
sir.
And another thing, we know from the brain, we are having a lot of cranial nerves which are moving out, which are moving out. So as the brain is herniating downward due to less CSF, so won't these cranial nerves be pulled with that? Won't we be having
Yes.
problems of cranial nerves? We'll be having problems of cranial nerves. We have blood vessels as well. So as the brain is herniating down due to less CSF, the buoyancy is decreased, the weight of your brain is increased. So you can simply think of it's also going to be giving you us a lot of headache as well, because whenever the arteries or the blood vessels are stretched, that basically makes some painful situation. That is, headache is going to be associated. So we are going to discuss these things in detail. What is the other function of CSF? CSF also helps in transport as well. Like, for example, transport of different Okay, so do you guys know what is melatonin? Anyone?
It is this hormone that is released for maintaining the sleep wake cycle.
Okay, maintaining the sleep wake cycle mainly. Okay, so it's going to be okay from which, I would say, part of your brain melatonin is secreted. What do you guys think? Hello, anyone?
Pineal gland?
Yes, it's going to be made by pineal gland, right? So this melatonin is going to be, helping in the sleep-wake cycle. How does the transport of this melatonin occurs? It occurs via CSF. So can I say that CSF is also really important for transport of different, you can say, hormones, right? Can I say that CSF is important for transport as well?
Yes.
Okay,
Hormone.
perfect. Yes, CSF also nourishes your brain, right? It also provides nourishment to your brain, right? What is the other function of CSF? Do you guys have any other function in your mind?
They help in shock absorbing.
Shock absorber, perfect. Like simply you can think of, let's suppose if someone is wearing a helmet, right? So we know that a helmet is going to be made up of steel, but in between helmet and your head, you have that foam kind of material present, right? Why do we have that foamy material? Because if someone get hit on his head while wearing a helmet, so this medium of the foam basically it absorb all of the shock, right? So same is the case with the CSF as well. It's going to be a shock absorber in the same concept we discussed once we were doing a fetus, right? Around the fetus, we have amniotic fluid. And what was the function of that amniotic fluid? By any chance, if the baby get, if the mother get hit by, by anything, so, that amniotic fluid is going to absorb all of these shocks. So here the concept is same. So you can see that CSF is surrounding your brain. It is providing a shock absorber kind of environment. So whenever we have any trauma to the head or anything, so this CSF is going to act as a shock absorber. Is it clear?
Yes.
Hello? Okay, perfect, right? So sometimes the CSF can increase in quantity, which we'll be discussing, that is hydrocephalus, right? So now we know the function of CSF. Let's discuss where the CSF is formed. Okay, where the CSF is formed. Do you guys have any idea?
Ventricles.
Ventricles. Perfect. So ventricles are basically hollow structures present within the brain. Different parts of your brain have different ventricles, and they have specialized structures, which we'll be discussing in a bit. Choroid plexus, which basically make your CSF. So what are ventricles? For example, if this is your brain, your cerebrum. So cerebrum have two ventricles inside it, right? Lateral ventricles. Okay. Lateral ventricles basically join with another ventricle which is present in the diencephalon. That is going to be your third ventricle. Is it clear? Hello?
Yes.
The third ventricle is going to be, coming down in the midbrain. You have cerebral, yes, aqueduct, right? Hello?
Yes.
Okay, perfect. After that, we have our pons and we have our medulla, right? So half of the fourth ventricle is going to be present within the pons, half of it in the medulla. So we have this tent-like structure, tent-like ventricle, which is called as fourth ventricle, and then we have our spinal canal in your spinal cord, right? Is it clear?
Yes.
It basically is having two ventricles called as lateral ventricles. Then you
Can
have
you please
third,
repeat?
yes,
Just
please.
the
Okay,
can
so
you
we have our cerebrum. Cerebrum have two hollow structures that are called ventricles. What are the function of ventricles? They make your CSF, right? Okay. So in the cerebrum, we have lateral ventricle. So we have two cerebrum, two hemisphere. Each hemisphere have one lateral ventricle. Is it clear? This lateral ventricle is going to be joining with the third ventricle present in the middle. So this is going to be your third ventricle. From the third ventricle, we have cerebral aqueduct, which is going to be present in the midbrain. Is it clear? Then after that, we have our fourth ventricle. Half of it is going to be present in the pons, and half of it is going to be present within the medulla. Is it clear? Hello.
Yes, yes.
Okay.
Yes, yes.
So, okay, so you can see the foramen which is present between your lateral ventricle.
But you are not audible.
You are not audible.
Hello, can you guys hear me now?
Yes.
Yeah,
Yes.
right now.
Okay, that's great. So we were discussing we have lateral ventricles in each cerebral hemisphere. Lateral ventricle is going to be joining a third ventricle in the middle. Okay. Then we have our cerebral aqueduct. So all of the CSF being made by the lateral ventricles are going to go through the third ventricle and into the cerebral aqueduct, which is present in the midbrain. Then we are having fourth ventricle. Okay. And after that, we have spinal canal within the spinal cord. Is it clear till now?
Yes.
So you can see we have two foramen which basically join the lateral ventricle with the third ventricle. What are these foramen? Can you just please fix your mic? Who's that? Okay. So you can see that the foramen which basically joins the lateral ventricle with third ventricle are called as foramen of Monro. Is it clear? Hello.
Yes.
So the CSF is going to be made inside the lateral ventricle. It's going to be moving through this foramen of Monro into the third ventricle. From the third ventricle, CSF is going to move down through cerebral aqueduct, which is going to be present within the midbrain, right? So we are going to be having one of few word MCQs. Maybe you guys might have done it with Dr. Hasnain. Whenever we have tumor of pineal gland, as we discussed, what is pineal gland? Remember, what is pineal gland? Hello.
The gland which releases melatonin and serotonin.
The gland which release melatonin. Okay, it's also known as third eye. Remember, right? Because it's going to be responsible for your circadian rhythms as well. Okay, so whenever we have pinealioma, that is tumor of pineal gland, it would most probably obstruct your cerebral aqueduct. Keep that in mind. So for example, if cerebral aqueduct is obstructing, so you can see that this CSF is going to build, it's going to back up and it's going to build back up. Am I right? And as a result of that, CSF is going to build a lot in these ventricles, due to which we are going to be having bilateral dilatation of these lateral ventricles. As we are just making a lot of CSF in the lateral ventricle, but you cannot drain it out due to obstruction of cerebral aqueduct. When do we have most probably obstruction of cerebral aqueduct? That's going to be due to a tumor of pineal gland, which can just come, which can compress your cerebral aqueduct. So as a result of that, the head circumference of a baby with cerebral aqueduct stenosis or compression is going to be really big circumference of his head. Why? Because the CSF is going to build back, which is going to dilate the entire head. And as we know, the babies do not have the fusion of his skull bone. The skull is really fragile, so it can easily extend, and you can have a big head, right? That's going to be hydrocephalus. Is it clear? Hello.
Yes.
Okay, perfect. So the CSF is going to move down. Can you please fix your mic, doctor? Okay. So the CSF is going to, come down, and via fourth ventricle, it's going to be moving into space, which is known as your subarachnoid space. So where do we have CSF? In which space do we have CSF?
Subarachnoid space.
Subarachnoid space. Perfect, right? So you can see here we have three foramens within the fourth ventricle. That's really important, right? These two foramens and one foramen in the middle that is opening towards the back. So you can just imagine, like, if I'm just looking towards the lateral view of this fourth ventricle, so it's going to be just like that, okay? Just like that. A funnel kind of structure which is going to enter into the cerebellum, because at the back we have cerebellum. Am I right? Hello.
Yes.
Okay, so these foramens basically are going to drain the CSF back into the cerebellum, where again it's going to open into a cistern. Cistern is basically a dilated structure of your subarachnoid space, and there all of the CSF is going to be drained out, right? So these two foramens which are present at the lateral aspects of your fourth ventricle, what are the name of these foramens? They are your foramen of Lashka.
Lashka Majandi.
And this foramen perfect, which is going to be
Majandi.
present in the medial posterior aspect of your fourth ventricle, is foramen of Majandi. Is it clear? And they're going to drain the entire CSF into subarachnoid space, and you guys can see this CSF is going to just move all around your central nervous system. It's going to circulate all around the central nervous system, and as they circulate all around the central nervous system, it would just move up, surrounding your brain, just like that. Okay, you guys can see I'm just drawing the pathway of entire CSF. And then this CSF, hello, any questions? Hello, hello,
Continue, sir, continue.
can you guys hear me well? Hello.
Yes,
Yes.
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 Yes,
Okay,
doctor, we can hear.
that's great. That's great. Okay. So as we discussed that once the CSF moves into the subarachnoid space, it's going to circulate all around your brain, around your spinal cord, around your brain, and here it's going to drain into some structure which we'll be discussing. So what do you guys? Okay, before discussing its drainage of your CSF, as you know that CSF is constantly being made by your ventricles, and it's also going to be drained somewhere here, which we'll be discussing in detail. But let's discuss that how initially the CSF is being made here, right? Okay. Hello.
Yes.
So let me just draw.
Yes.
Like this portion of your ventricles, and let me just zoom it in, right? Can you just please fix your mic, Doctor Hub? Hello. Okay. So
Yes.
can you just please fix your mic? It's really noisy. Okay. So as you can see, for example, if these are your ventricles, your lateral ventricles, right? And this is the, the width of the lateral ventricles. So you can see that here, first of all, we are going to be having an artery called as choroidal artery. So choroidal artery is going to pierce into the width of this, of your lateral ventricles, and it's going to enter into the space of the lateral ventricle. So it's basically your choroidal artery. Okay, and this choroidal artery, once it's moving, it will also just take a layer of pia mater along with itself, and the pia mater layer is going to be present upon this choroidal artery. Is it clear? Hello.
Yes.
Okay.
Yes.
And another thing which you must know, is that we have certain cells which basically lines, the inner portion of your ventricles. These cells are basically called as ependymal cells, right? Ependymal cells. So as the arteries passes into the as it's facing into the ventricles, so it would take a layer of pia upon itself, and upon the pia mater will be having these ependymal cells present on the surface of this artery along with pia mater, right? So we have three layers. We have arteries entering into the ventricles. Upon the artery we'll be having pia mater, and upon the pia mater we'll be having the ependymal cells. Is it clear? And collectively this structure is going to be called as, yes,
Choroidal plexus.
choroid plexus, right? Collectively, this structure is going to be called as choroidal plexus. So
Can
how
you
this
please
choroidal
repeat
plexus?
this?
Okay, sure. We discussed we have our lateral ventricles, right? Okay. Hello. These are our lateral ventricles. This is our third ventricle, right? Foramen
Yes.
of bone. Okay. First of all, a blood vessel. Okay. How do we make CSF? So for making of CSF, we need an artery to pierce into the to pierce into the lateral ventricle. So this artery is going to pierce into the lateral ventricles, right? And it would be, entering into the lateral ventricles. And as it is entering into the lateral ventricles, it would just pull the pia mater. We know that the pia mater is also going to be present. Where pia is basically going to be present close to your brain in order to give good parenting, or we can say support directly to your brain structures, right? Or your neural tissues, right? So upon that, we'll be having these pia mater structure, which is going to surround this choroidal artery. It's simply an artery, okay? And upon the pia mater, we'll be having these ependymal cells, right? So we have formed three layers: a blood vessel surrounding a pia mater, surrounded by ependymal cell. Collectively, these structures or these complex of three layers is called as choroid plexus, right? And CSF is going to be made by these choroid plexus. So let's discuss how CSF is going to be made by these choroid plexus. Okay, so we have different pumps and channels which are present in the blood vessel here, right? In these plexus, right? So one of the pump is going to be your Na pump, right? So what the Na pump is going to do? Na is going to dump off sodium from the blood into the lateral ventricle space. Is it clear?
Yes, sir.
Hello? As
Yes.
Na is a positive ion, so what this Na would do, it would just attract all of the negative Cl ion from the blood as well. So in the end, we'll be having NaCl, which is salt, right? Hello?
Yes.
Yes.
Okay.
Yes.
We know
Yes.
this NaCl basically is osmotically active agent. What do you mean by osmotically active agent? They are good osmoles. They can just pull water from the blood vessel. So as we have NaCl there, it would just pull a lot of it will just pull a lot of water with itself. So in the end, we have NaCl plus H2O. Am I right?
Yeah.
Yes.
Hello? Okay.
Yes.
Okay. Okay. So what else would happen here? We are going to be having different channels for glucose as well, right? Different transporters for glucose as well. So those channels are going to put some glucose into the, into the space as well. So in the end, now we have glucose as well here, right? We also have glucose. So NaCl plus water plus glucose. Is it clear? Hello?
Yes.
Yes.
And in the end, we have another channels for potassium as well, which is going to dump some potassium into the space as well. So in the end, we have NaCl plus H2O plus glucose and plus potassium. And collectively, this is your CSF, which is a clear fluid. Is it clear?
Yes.
Okay. So let me just repeat it again. Na is going to be dumped into the space. As it is a positive ion, chloride is going to follow. Okay, just let me just mute your mic. I think it's making a lot of disturbance. Hello?
Yes, sir.
Yes,
Just
doc.
okay. So as we discussed that Na is going to be dumped out into the space as it's a positive ion, so negative ions are going to move and it's going to attract that positive ion. In the end, we'll be having Na plus Cl. That's simply a salt, right? And this NaCl is going to be, it's an osmotically active agent. It can pull water with itself. So it would just pull water from where? From the blood vessel, from the solar plexus. Then we have different transporters for glucose and different transporters for potassium. They'll just dump some glucose and potassium, and in the end, this entire mixture is your CSF. That's so simple. So as we were discussing CSF is basically a mixture of your NaCl, like even we can make CSF in our home as well. Just take some salt, uh, just take some salt along with that. Take some glucose, take some potassium. You are having a clear watery kind of consistency, fluid, which is going to be your CSF. So this is going to be the CSF, which is going to provide nourishment, that is glucose and everything to your brain. And it's going to, as we discussed, different function. It's going to be a transport medium for different hormones as well. It's also going to provide the buoyancy force, which is going to decrease the weight of your brain, which is really important. If the CSF is less, it means that the brain is going to herniate downward, which is going to cause a lot of problems. So as the CSF circulate all around the brain, so in the end, the CSF is going to be drained as well. So how the drainage of CSF occurs? Do you guys have any idea? Yes.
Yes, it drains to the
Artificial.
arachnoid villi level.
Okay, the arachnoid
Villi.
villi. Okay. So the arachnoid villi are going to drain the CSF where? Do you guys
Into
know what
the
are sinuses?
From the
sinuses.
ventricle to the
Okay, do you
outside.
guys know what are sinuses? Sinuses are basically, hollow structures, I would say, in which the venous blood flow, right? They're called as sinuses, right? Hollow passages or canals or structures in which your venous blood is flowing. Inside your brain, there are sinuses, right? So we have different sinuses within the brain. We'll be discussing that: superior sagittal, inferior sagittal, petrosal sinus, cavernous sinus. We are going to discuss each and every sinus in big detail, right? But you should know what is sinuses. These are some hollow structures in which our venous blood is flowing, right? So we have a sinus called as superior sagittal sinus. What is superior sagittal sinus? For example, if this is your brain, right? Or okay, your skull, right? So we know that the brain, okay, this is your brain, okay? We know that the brain is basically lined by layers called as meninges. You guys know that? What are meninges? Hello?
Yes.
They basically provide support to your brain. So we have three layers of meninges. What are they? The one closest to your brain is, as I already discussed,
Paya
yes,
matter.
it's going to be your
Paya
pia
matter.
matter, right?
Pia matter,
Pia,
arachnoid matter, dura matter.
perfect. The next one is going to be our arachnoid matter, right? And the last one, which is the going to be the toughest one, you can say is going to be your which matter? Your
Dura
dura
matter.
matter, which is going to be close to your, skull bone, right? Okay. Okay. So as we know that CSF is going to be present here. So the CSF, okay. So you can see this dura matter here in the superior sagittal aspect of your brain. This is the sagittal aspect of your brain. Okay. It's going to be dividing, this dura matter is going to be divided into two parts. The one attached to the periosteum bone and the other attached down to your arachnoid. They are going to make a space in between that. And what is that space called? That's
Sagittal sinus.
okay, that's sagittal sinus, right? So you can see that. Okay, let me just draw. So here, okay, just give me a second. Okay, so here you can see that these dura matter are going to be separated from one another here in this aspect. Like we are going to be having, the okay. Let me just draw it first. Okay, so this was your dura matter, right? So we have two component of dura matter here as well. The one which is attaching towards the bone, which is known as periosteal, and the other which is attaching to arachnoid. So here in this aspect of your brain, both of these dura matter are going to separate from one another, and they are going to form a canal kind of structure or a sinus in which basically our venous blood flow. And this sinus is called as superior sagittal sinus because it's present in the superior sagittal aspect of your skull. Is it clear? Hello? Hello?
So could you kindly repeat it?
Okay. Okay. Okay, this is your, okay, this is a normal human being, right? Okay, I'm just drawing his ribs, his chin and everything, right? His neck. Okay, really sorry for his neck. We discussed that, okay, this is his brain, right? This is brain of an individual. I'm just drawing some gyri, okay? We know that the brain basically is going to be covered by layer of meninges, right? Meninges basically covers your brain. We have three layers of meninges. Pia matter, which is going to be present closest to your brain. This is your pia matter. Is it clear? The other one is arachnoid matter. Is it clear? So this layer, the blue layer, is going to be your arachnoid matter. Is it clear? The last one is going to be your dura matter, which is going to be present, outside or above your arachnoid matter. Is it clear? Hello?
Yes, sir. I was just looking for the last bit of it, what
Okay.
you said.
The dura matter here is going to be further divided into two parts. It's separate from one another. The dura is, like for example, if this is your dura, so it's separate in between, right? You can see, and it just form a kind of sinus, a hollow canal. That's a sinus in which our venous blood basically flows, right? So we have these two layers. The same single dura matter have two layers, the one attaching to periosteum bone, the other attaching down to the arachnoid, and in between they have space. That space is known as superior sagittal sinus, in which our venous blood is flowing. Is it clear now?
Yes, sir. Thank you very much.
Okay. So whenever this CSF enters all around, it circulates all around the brain, all around the spinal cord. So what would happen? We have a structures which are known as arachnoid villi. So arachnoid villi are basically a kind of, you can say fingers like projection, which are going to project from subarachnoid space into the superior sagittal sinus. And via these arachnoid granulations or these arachnoid villi, the CSF is going to be pushed into the into the superior sagittal sinus. So CSF is going to be pushed here into the superior sagittal sinus via these arachnoid villi. Is it clear? Hello?
Yes, sir.
Okay, perfect. Okay, so as these CSF is pushed into the superior sagittal sinus. From the superior sagittal sinus, where this CSF is going to go? Do you guys have any idea? Hello?
Internal jugular vein.
Okay, in the end, it's going to go to internal jugular vein. But we are going to discuss different sinuses in detail. So superior sagittal sinus is going to lead to occipital sinus, the petrosal sinus, which we'll be discussing in detail. And in the end, it's going to drain into the internal jugular vein. So you guys can see here, CSF, the entire pathway of CSF. Let me just revise it again. We have hollow structures within the brain called as ventricles. The ventricles are going to make CSF. Okay, which ventricles do we have? In the cerebrum, we have two hemispheres having two lateral ventricles. Right, lateral ventricles are going to be joining in the third ventricles via foramen of Monro. Third ventricle is going to come down through via cerebral aqueduct in the midbrain, which is going to drain all of the CSF into the fourth ventricle. Fourth ventricle have three foramens, two lateral lush cast, one posterior, that is Magendie. They are going to drain all of the CSF into the cistern or the subarachnoid spaces. From the subarachnoid space, the entire CSF is going to circulate all around your spinal cord, all around your brain. In the end, it's going to get into, superior aspect of your skull. There, the arachnoid granulation, which are basically connection between the subarachnoid space and superior sagittal sinus, they are going to push all of the cerebrospinal fluid into the superior sagittal sinus through the sinus through different sinuses. In the end, CSF is going to be drained into internal jugular vein. So this is the entire connection. Am I right? Hello?
Yes.
Okay, let me just tell you a concept, right? In order to examine the CSF, we basically do lumbar puncture. Do you guys know that?
Yes, from L3 to
Yes.
L5.
Yes.
L3 to L5.
L5.
We do lumbar puncture, right? So what did we do? We just insert a needle, and once we enter into subarachnoid space, you know, we are going to drain that CSF, right? For example, if I am, if I have inserted a needle into subarachnoid space and I have attached a manometer. What is manometer? Manometer basically records pressure, right? Okay, let's suppose I have attached a manometer. So what do you think? For an individual, if I am just via my fingers, if I'm just blocking his jugular veins, would the pressure of CSF increase or not?
Yes.
Yes.
Yes. Yes.
Yes, that makes sense. If I'm blocking of the jugular veins, CSF is going to build backward. And as the CSF is building backward, it's going to accumulate. And as it gets accumulate, what happens? The pressure of the CSF would increase, which I can easily record via a manometer, right? So the significance of this is that we know the entire pathway connection, right? So the CSF is being made and it's being, you know, circulated. Is being, dumped in the end into the venous system, jugular vein, right? So in this entire pathway, whenever we have any kind of obstruction, whenever we have any kind of problem, that's going to lead to increased CSF pressure, which is also called as hydrocephalus, right? And hydrocephalus itself can cause a lot of problem. One thing which you should just keep in mind, the CSF is also present around the optic nerve as well, right? So we have optic nerve, and around the optic nerve, we have the CSF as well, right? That's really important to know. Why? Because in hydrocephalus, we are going to be having something called papilledema, right? Papilledema. What is papilledema? As we have hydrocephalus, it means that the pressure of CSF is going to be a lot, right? It's going to be increasing. So that sometimes this CSF can increase around the optic, optic nerve. We have optic vessels are also present here in the, we are going to discuss it in eye in detail. So sometimes this increase, cerebrospinal fluid pressure can compress the veins, of your eye, and it can lead to edema there, which is going to be papilledema, right? We're going to discuss it in detail. But here you should also know that the CSF is also going to be present here, right? Okay, if you guys remember one thing from your endocrinology, do you guys remember empty cella syndrome? You guys can't forget it, please.
Yeah, empty cell ataxia.
Yes.
Yes.
What happened in empty cella syndrome? Do you guys remember?
Yeah,
Yes.
somewhat some with
Subarachnoid
bony
cistern goes
structure.
inside the cellus turcica and pushes the optic pituitary gland, and it looks like an empty cella in MRI.
Perfect. As we discussed that we have sella turcica, right? And in the sella turcica, we have this pituitary gland. And we discussed that it's going to be lined by these, all of the meninges, and sometimes the CSF can enter here into the sella turcica. It can compress your, it can compress your pituitary, and due to chronic compression of pituitary gland is going to undergo degeneration. So in the end, the cella is going to be empty, which is going to lead to hypo or hyperpituitarism. What do you guys think?
Hypo.
Yes.
Hypo. Yes. Okay. So this was all about CSF. Now let's discuss the composition of CSF, right? We discussed that.
I didn't got the last line.
Hello?
Doc, you said that the CSF is formed, is circulating in between the duras. Then again, you said that it is in subarachnoid space. Why is that so?
Okay. Okay. Got it. Listen. CSF is always present in the subarachnoid space. CSF is always present in the subarachnoid space. But once the CSF come here at the superior aspect, we have to drain out the CSF. Like we need a proper flow of CSF, right? A proper flow of CSF. If you guys remember, okay, let me just give you a concept of like in almost every system of your body. If you guys remember, we discussed Porter syndrome. Remember Porter sequence, right? What was Porter sequence? If these are your kidneys of your fetus, they will just make urine, right? Urine is basically your amniotic fluid, right? This amniotic fluid is going to be made by the kidneys, and it's going to be swallowed by the baby, right?
Yes.
Yes.
And in this way, you are making amniotic fluid, and you're circulating, or the baby is drinking amniotic fluid. That's why we have constant value of amniotic fluid. And we discussed if the kidneys aren't functioning, it means less amniotic fluid is going to be present, which is going to lead to oligohydramnios. Remember?
Yes.
Yes.
Because in this case, amniotic fluid is being made less, right? Okay, we discussed if you have anencephaly, which is basically a big topic of your neurology, right? That is, if you do not have formation of proper mouth, the baby cannot swallow CSF. If the baby cannot swallow CSF, CSF is going to be built. So it means that we need a proper flow. Okay, it's not CSF, sorry, it's amniotic fluid, right? That is going to lead to polyhydramnios. Remember? Okay, it means that the amniotic fluid should be made, and at the same time it should be reabsorbed. It should be made, reabsorbed. It should be made, reabsorbed. So here we have a cycle going on, which is making your amniotic fluid and reabsorbing, making and reabsorbing, or you are drinking, or the baby is drinking, right? And same is the case with CSF. We have to make CSF, and we have to drain out CSF as well, right? Hello?
Yes, yes.
Yes.
Okay, so CSF is present within the subarachnoid space, but when the point come towards the reabsorption of CSF, we have to push CSF into those sagittal sinuses, right? We have to push it in between the dura, what you are saying, right? It's not
Yes,
present
yes,
between the dura. But in order to reabsorb the CSF, in order to get rid of the CSF, in order to have constant amount of CSF, we have to make CSF and we have to reabsorb CSF, right? So for that reabsorption, the arachnoid villi or granulations are going to push CSF into the superior sagittal sinuses and to all the sinuses. In the end, it's going to enter into the internal jugular vein. Is it clear?
yes, yes, doc. Now it's clear. Thanks a
Okay.
lot.
Okay, you are welcome. So let's discuss composition of CSF. Okay, remember CSF is a clear fluid, right? Clear fluid, right? Normally it have less than 5 lymphocyte present within the CSF. The lymphocyte concentration, okay, let me just write here, right? Okay, so CSF is basically a clear fluid, right? Can you please fix your mic? Whose mic is it? It's making a really disturbed, environment. Please just fix your mic. I don't want to close mics of students, because I want to have like, a proper discussion here. You guys can just ask me questions. So please just do take care of that, right? Okay, so CSF is basically a colorless or a clear fluid. We have less than 5 lymphocytes present. We do not have any neutrophils present within the CSF. Keep that in mind. The glucose concentration normally in CSF is 66% that of the plasma glucose level. Plasma glucose level. It means that here, once we were discussing that your blood vessel is going to dump glucose into the lateral ventricular space. It means it can only, it can only dump off 66% of glucose, right? So as you compare the concentration of glucose in the CSF with the blood, it would always be less. 66% of that of glucose in your plasma or the blood. Is it clear? Hello? The protein concentration is only 0.4 grams per liter. Is it clear? These are the normal values of your CSF. Okay, let me just repeat it again. It's a colorless clear fluid, right? It have less lymphocyte, even though less than 5. It do not have any neutrophils in a normal individual, right? Okay, it have 66% of plasma glucose level as compared to that of, as compared to plasma, it have only 66% of glucose, right? Sometimes you can have inflammation of your meninges called as meningitis. Meningitis is a big, extensive, topic which we are going to discuss. We can have bacterial meningitis. We can have that's called pyogenic meningitis. We can have TB meningitis. We can have viral meningitis as well, right? So how to differentiate whether the meningitis is due to a bacteria, whether it's due to TB, or whether it's due to virus? That's really important to know, right? So if whenever we have meningitis due to any bacteria, okay, which bacteria can cause meningitis? You guys already have did the microbiology, so I think you would better know.
Nigeria.
Nigeria.
What else?
Group B. Group B
Listeria.
pneumonitis.
Listeria.
Okay,
Strep
what else?
pneumoniae.
Okay, can any fungi cause meningitis?
Cryptococcus.
Yes.
Neoformans, right?
Yes.
Yes.
Cryptococcus neoformans, yeah.
Yes, cryptococcus neoformans. Okay. Okay. Viruses can also cause meningitis, right? You guys better know that because you guys are actively doing your microbiology session. So I think you guys are going to know more than me, right? Okay. So we can have bacterial meningitis. We can have TB meningitis. We can have viral meningitis. Let's differentiate them. What will be present in the CSF once we have bacterial meningitis, right? Okay. So whenever we have pyogenic meningitis, the color of CSF is going to be yellow and turbid, right? Turbid and yellow. It would be same as like close to pus. Pus is turbid, right? And having yellowish kind, right? Hello? And what is pus we discussed? Pus basically is your dead neutrophils. Along with that, we have some dead, dead neutrophils and dead debris, right? So it's going to be yellow and turbid, right? What are going to happen whenever we have bacterial infection, which cells are going to rise? The lymphocytes or neutrophils? What do you guys think?
Neutrophils.
Neutrophils.
Neutrophils are going to rise, right? So can I say that normally we do not have neutrophils, but in case of pyogenic bacterial meningitis, neutrophils are going to rise. What will happen to lymphocytes?
Below.
They would be low. Right?
Below in bacterial meningitis. Yes.
Yes, they would be low.
Only in
Remember
TB.
one thing. Sorry. Hello? Remember one thing.
Hi.
There is a mnemonic. There is a mnemonic. That's that bacteria eats glucose and they shits protein. Okay. But okay, it's a little bit funny, but you should just remember, right? Bacteria basically eat glucose and it shits protein, right? But what's the main thing? Why do we have? So it means that what will happen to the glucose concentration in the CSF once we have bacterial infection?
It will decrease.
It would decrease less than 50%
Decrease
of
to
that of
below.
your plasma. If you compare it with the plasma, it would be less than 50%. What will happen to the proteins concentration? Proteins would rise a lot. And we know that why. Whenever we have bacterial infection, we know that the blood vessels which are present, the permeability of blood vessel increases, right? And as the permeability of blood vessels increases, the proteins are going to move into the CSF. Is it clear? So in any questions, if you have labs, these labs are going to help you, whether it's a bacterial meningitis, whether it's a TB, which I'm going to discuss in a bit, whether it's a viral meningitis. So let's discuss about viral meningitis now, right? Viral. Whenever the viruses cause meningitis, remember the CSF there is going to be clear. We won't be having that pus formation. We know that viruses do not lead to any pus formation. Which cells fight viruses? We discussed it in immunology in detail. Yes, which cells? Hello.
The B cells.
T lymphocytes. Remember?
Lymphocytes, yeah.
T lymphocytes. We discussed it, if you guys remember, right? Okay. So what will happen to the concentration of lymphocytes whenever it's a viral meningitis?
Increases.
It would increase a lot. What will happen to the level of neutrophils whenever it's a viral meningitis? That would be normal. No neutrophils, right?
Yeah.
And remember, okay, what will happen to the level of glucose and the level of proteins? What do you guys think?
Glucose will be normal and the protein will be high.
Increase.
Normal glucose. And what happens to the protein?
Will be high.
Increase.
Okay. Would increase? No, the protein won't increase. The protein are going to be a little bit high, not as much as high as compared to your bacterial meningitis. Keep that in mind, right? Okay, that would be
Yes,
high, but not
normal,
as
normal.
much as that of normal or little bit high. Okay, so it's going to be the viral meningitis. Okay, what happens in TB meningitis? That's a little bit, different. In TB meningitis, what would happen to the color of CSF? The color again is going to be turbid, but we are going to be having fibrin webs. Keep that in mind, right? So whenever the TB causes meningitis, it can also lead to communicating hydrocephalus as well, right? So whenever we have, let's suppose meningitis here, TB, in the end, it's going to be leading to fibrosis. And as we have fibrosis here, it's going to lead to hydrocephalus again, because the CSF is going to build back, and we are going to be having, dilatation of all of the ventricles, right? But that's a communicating hydrocephalus. So what is communicating hydrocephalus and what is non-communicating hydrocephalus? Let me just make it simple. Whenever all of the ventricular system are in communication with one another and still we have hydrocephalus, that's communicating hydrocephalus, right? Okay, like here you can see the problem, the fibrin is basically going to be deposited in the subarachnoid space, right? As the fibrin is present here, we cannot drain out the CSF. The CSF is going to build in the ventricles, right? But still all of the ventricular system are in communication with one another. Am I right? The ventricles are in communication with one another. So we are having communicating hydrocephalus. Does that make sense?
Yes.
Okay, and what is non-communicating hydrocephalus? We will be discussing it in detail in Chiari syndromes, a lot. Whenever we have problems here within the ventricular system and the ventricles aren't communicating one with one another, and it's leading to hydrocephalus, increased CSF. So that's going to be your non-communicating hydrocephalus. Is it clear? Hello?
Yes.
Yeah, it's clear.
Okay, perfect. So how can we have hydrocephalus whenever mostly the drainage is less? That's going to lead to hydrocephalus, right? If you are draining the CSF, it would build up, and as it build up, it's going to lead to hydrocephalus, right? So we were discussing TB. In TB,
Yes.
meningitis, the color is going to be turbid, but in the end, we are going to be having fibrin webs within the subarachnoid space, which is going to lead to, yes. Communicating. Okay. So remember, in TB meningitis, the concentration of the neutrophils would be normal,
Decrease.
while the lymphocytes concentration is going to increase.
Communicating hydrocephalus.
Okay, is it clear? And again, the TB again is going to eat your glucose, so the glucose concentration is going to be less, while the protein concentration is going to be more. So this is going to be same as that of bacteria. It's a bacteria, right? But here the difference is in the lymphocyte. We are going to be having lymphocyte response, with TB meningitis. Is it clear? Hello?
Yes, doctor.
Okay, so let's just cover this topic from our first aid, right? Okay, just give me a second. Let me just open the first aid. Can anyone just please tell me the page number of first aid page number?
First aid. 506, doctor.
Okay, the ventricles, ventricular system. Okay, so here we have ventricular system. Okay, let me just share my screen first. Can you guys just see my screen now?
Yes.
Okay, you
Yes.
guys can see here. Okay, so okay, we discussed we have lateral ventricles. Can you guys just see my screen properly?
Yes.
These
Yes.
are our lateral ventricles. You guys can see it here, right? Lateral ventricles. Lateral ventricles are going to be joining with the third ventricles via foramen of Monro, right? So this is your third ventricle. You can see via foramen of Monro, right? Then we have cerebral aqueduct. Cerebral aqueduct is also called as aqueduct of Salvius as well, right? Okay. Then we have cerebral aqueduct or Salvius, which is going to be joining your fourth ventricle. Here you guys can see fourth ventricle is going to drain into subarachnoid space via Lashka laterally, Magendie medially. Lashkas and Magendie. Am I right?
Yeah.
Hello.
Yes.
CSF is made by choroid plexus located in the lateral third and fourth ventricle. We know that what are choroid plexus. Blood vessel.
And foramen Magandi is medially.
Yes, perfect. Medial and posteriorly, right? Medial and posterior. Okay. We discussed CSF is going to be made by your choroid plexus located in the, all of your ventricles, travels into the subarachnoid space via Lashka and Magendie, reabsorbed by arachnoid granulation, drains into dural venous sinuses, superior sagittal sinus. Is it clear? Hello?
Yes.
Yes, doc.
What happened to my first slide? Okay. You guys can
Yeah,
see
yeah,
the
it's
peripheral
clear.
venous sinuses, right? So we have large channels, so the periosteal and meningeal layer of dura mater. I just told you the one attached to your periosteum is going to be the periosteal layer and the dural layer. In between, we are going to be having a space that's going to be superior sagittal sinus, right? Blood is going to be drained and it's going to receive CSF from arachnoid granulation. Remember, we did it. Empty into internal jugular vein. We know that venous sinus thrombosis. Whenever we have venous sinus thrombosis, the sinus get thrombosed. So what would happen? Present with sign and increase of intracranial pressure. Are we going to have hydrocephalus whenever the dural venous sinuses get obstructed?
Yes.
Okay.
Yes.
Is it going to lead to a headache?
Yeah.
Yes.
Why?
Yes.
Because if you have a lot of
Pressure.
CSF surrounding the
Pressure.
brain, it's going to
Pressure.
make a lot of pressure. The pressure is going to pull a lot, pull or push a lot of blood vessels, which is going to lead to headache, seizures as well. A lot of CSF can compress the different parts of your brain, and due to compression of different parts of your brain, the electrical activity within the brain is going to be disrupted, which is going to give you seizures, right? Hello.
Yes.
So
Yeah,
we
we got it.
discussed it can lead to papilledema, as we discussed that. CSF also runs around your optic nerve, optic vessels, or ophthalmic or your retinal veins, retinal blood vessels. So whenever we have hydrocephalus, it's going to obstruct the veins, and as the veins are obstructed, the buildup of blood within the arteries is going to lead to edema, giving you papilledema, right? And focal neurological deficits as well may lead to venous hemorrhages, right? Associated with hypercoagulable state. If we have hypercoagulable state, that's going to lead to thrombosis, right? And we know what lead to hypercoagulable state. We did it in detail. Pregnancy lead to hypercoagulable state. Why? Hello.
Increase demand.
Increase estrogen. Does increase estrogen along with smoking lead to hypercoagulable state as we discussed? Yes or no?
Yeah, yes.
Yes.
Oral contraceptive pills are basically combination of progesterone and estrogen again.
Hormones.
Would it lead to thrombosis?
Yeah.
Yes.
Factor 5 Leiden mutation. If you guys remember, protein C and protein S normally inhibits your factor 5. If you guys
Factor
remember,
5.
and if you have mutation of factor 5, they won't be inhibited by protein C and S. And if they won't be inhibited by protein C and S, it's going to lead to Hypercoagulable state, you know
Coagulation.
that,
Yeah.
right? Hypercoagulation,
Coagulation.
we did it in detail. So it was all about today's lecture. Hope so you guys enjoyed the session and you guys better. Okay, so neuro is no proper understanding. Once you have proper understanding of the neuroanatomy which we are discussing, then you guys are going to be really easy with pathologies and everything, right? So we just took a lot of time on it and hope so it's clear now. That was all for today. The time is over. Thank you and see you tomorrow. Thank you so much, doctor.
Thank you, sir.
Thank you.
Thank you,
Thank you.
doctor.
Thank you. Thank you.
So the neuro is going to be finished, within this week. I'm going to increase the timing of these sessions, and this week we are going to be done with neuro, right?
Okay, doc.
Doctor,
Thank you.
can you repeat what is non-communicating hydrocephalus?
Okay. I'm also going to do it in detail once we are just doing pathology. In pathology, we have a proper topic of hydrocephalus. We have different types of hydrocephalus. So there it's going to be more clear, but let me just give you an overview, right? We have
Yes.
lateral ventricles, the third ventricle, cerebral aqueduct, fourth ventricle. Oh, what I did. Let me just make it again. We have lateral ventricles. We have foramen of Monro. We have our third ventricle. We have our cerebral aqueduct. Then we have our fourth ventricle. And from the fourth ventricle, we have spinal canal. We know that all of these ventricles are communicating with one another, right? If, for example, we discuss a condition in which cerebral aqueduct is going to become stenosed or compressed by a pineal gland tumor, right? So if we have compression of cerebral aqueduct or aqueduct of Sylvius, now the lateral ventricles aren't communicating with the fourth ventricle. No communication between the ventricle, right? Am I right? So it's called as, we're going to be having hydrocephalus. CSF is going to build. So it's going to be non-communicating hydrocephalus.
Okay. Thank you.
Okay. And once we have communication of all of the ventricles, but some problem occurs in the subarachnoid space, that's going to be leading to communicating hydrocephalus. Because again, all of different, ventricles are communicating with one another. Is it clear?
Yes, it's clear now.
Thank you so much. Thank you. Hope so you guys
Doctor, please,
enjoyed.
I have a question.
Yes,
Can
please.
you repeat what you said about CSF with seizure? The area where
Yeah.
you mentioned about seizure?
Okay, sure. For example, if you have hydrocephalus, right, it means that the CSF pressure is going to be really high around the brain. For example, if this is your brain tissue, right, so the pressure here is going to be really high in hydrocephalus, right? Hello?
Yes.
Hello?
Yes, doctor.
That increased CSF pressure is going to compress the brain matter, right? Can you please? Okay. So this increased pressure is going to sometime, compress your brain structure. And as we are compressing the brain structures or your brain parts or mesenchyme or the tissue of your brain, it can disrupt the electrical activity of your brain. And once we have disruption of electrical activity inside the brain, it can lead to seizures, which we are going to discuss in detail. Different seizures. Is that clear?
Yes, doc. Thank you.
Thank you so much. Thank you and see you tomorrow.
Doc. Hello.
Hi.
Oh, he's
Yes,
gone.
please.
Oh, you're here.
Doc, would
Okay.
there be any
I
session?
also have a question.
Yes.
I'm sorry. You can go ahead, I guess. Nargis Ahmed. If you have a question about the session, I don't have. It's not about the session. My question is not about the session.
No, you can ask.
All right. Thank you. Dr. Ahmed, I was wondering if the UWorld questions that are followed with the sessions are for the new marathon or already it's for the old marathon. I was a bit confused about that. If you can clear that up for me.
Okay, so you know that we are just doing UWorld sessions along with each and every, like, they're for everyone, right? So as we are doing neuro now, so Dr. Hassan is also going to do neuro. One concern which I have heard from the student is that, like, we are doing CSF and there you are going to be having some pathology sessions, right? But one thing which I want to clarify is that UWorld session is for your learning, right? That's also for your learning. Just go, just sit there, just learn something, right? although we are going to do it in our sessions in detail in pathology, right? But UWorld isn't your, and one thing, please, it's a request, those who already know the content, so please don't like, start answering in the sessions, because a lot of students are feeling really demotivated. You guys already did it once, but, not all of the
Yeah.
students like at same, board. So please just take care of other students. Believe me, they get demotivated, to be honest, right? Because it's their first. You guys already have done it once, twice, right? You know the content, no problem. But for the other students, since it's their start, we need to motivate our, the students who are new, who haven't done it, right? Once those, they, those students who just did, who did do take these sessions and then do start practicing you world, obviously it would just take time. It's a process. You guys have to, trust the process. You guys have to revise the content again and again, again and again. Please do take care of them, right? Those who know the answer, those who know the knowledge, just keep it with yourself, right?
Yeah.
Okay, just keep it with yourself. The reason is that those students who are new, they get demotivated, right? And those are, you world itself isn't an assessment tool, it's a learning tool. You guys are going to learn how to read a question, how to read a question. So these UWorld session with Dr. Hasning, he's just putting in a lot of effort. He's just explaining each and every question of UWorld, how to read, how to sync it with first aid, how to synchronize it with your study, how to apply the concept, right? So once you know it, how to apply, then knowledge is easy. You can gain knowledge. You can just take the session with me. You will be having a proper knowledge of each and every pathology. And those students who do not understand the UWorld session, no problem. You guys can still sit there. You guys can observe things, because it's not that you are going to have this session and you'll be able to solve UWorld. UWorld is not an assessment tool. It's a learning tool. Just learn it. Already you guys are going to get your recorded sessions. Once you know the content, just go through those recorded sessions again, and it will just make a lot of sense. If you guys haven't done
Doc,
anything, just please.
would there be a session of viewer today?
Yes, we are going to be having a UWorld session today. Okay.
So like on a daily basis, we'll be covering
Uh,
this.
Yes, for the marathon students, it's a daily basis, and it was last day for those students who are outside the marathon. Those who want to join the marathon, they can just text me, and we can just discuss about the plane and everything, right? But those students who are, who are getting confused, just please just take it easy. Just trust the process for 1 or 2 weeks. Those who are new, believe me, everything is going to be very easy. And these neuro and cardio, especially, they are the, a little bit
Sure.
confusing system. They need a lot of space repetition, right? Those who haven't followed us on Insta, just please do follow us on Insta. There I basically just, give some tips of studies, that they are going to help you a lot, right? About the space
Sir,
repetition.
can you pin the ID, Insta ID there somewhere in the group or here?
Okay, I'll just share the Insta there. So daily, I'm just posting some tips, about space repetitions, about everything. So just do follow Insta, and you guys are gonna get really good content there. Okay.
Could you please paste that here in the call chat, the group link and the Insta link?
Sure. I'll just paste it. Okay. Those who have those who want to know and further about the program, so they can just text me as well. And can we get notes of the? Yes, I'll just share the notes, and you guys can just share it. You guys can just reach me out, and we'll just discuss on it. Okay. Thank you so much.
Please, when are we doing the boot camp, MSK, and then assessment?
For the MSK, we are going to do it on next Saturday and Sunday, because I'm just trying to wind up. Like a lot of students are just complaining me that we have to cover these neuro sessions, because at the same time they're doing their U word as well, right? So that's why we have decided that we are going to have those boot camp session on next Sunday. Okay. Hello.
Okay.
Okay, sure. Thank you so much. Thank you, and have a nice day. See you tomorrow.
Is Miriam there? Miriam. Myram.